Hi, welcome to Module 2 of an Introduction to Engineering Mechanics. Here are the learning outcomes for today's module. First, we're going to describe and list examples of scalar quantities, and then we're going to look at vector quantities and do the same thing. This will be followed by looking at the concept of a force and explaining what a force is. And then finally, we'll learn how to properly label a force to completely describe its characteristics. So let's start out with an exercise that you'll do. I'd like you to take some piece of paper or maybe on your computer and write down what is meant by a scalar quantity. And you can research this. You can go to Google or a textbook, if you will. Try to figure out what a scalar is and then list a few examples of scalar quantities. Okay, now that you've answered that question, let's look at what a scalar quantity is. A scalar quantity is just a value, and I've put down a mass, the letter m, as a typical scalar value, and that's how we would describe it. It has a magnitude. Mass would have a magnitude of kilograms, but it has no associated direction. Some other examples are listed at the bottom of the screen. You've got volume, time in seconds, volume maybe feet cubed or meters cubed, and then speed. Speed's a good example of a scalar. We can take this truck again, this cherry picker truck. It would have a speed of, say, 30 miles an hour. Okay, and so that's the magnitude. It's actually the magnitude of the velocity. And we're going to talk about the velocity as a vector on the next screen. And density is also a scalar quantity, and temperature could be in degrees Fahrenheit, degrees Celsius, degrees Kelvin, but it's just a value. So next, I'd like you to go ahead and describe what is meant by a vector and also give me some examples of vector quantities. And then when you finish that, you can start back up again. Okay, let's go ahead and look at vector quantities. A typical vector quantity, which we're going to talk a lot about in this course, is force, often given the symbol F. And we put a line above the force that designates it as being a vector. A vector has magnitude, just like a scalar does, but it also has direction. And so examples are a force or a moment, and we'll use those a lot in this course and learn a lot more about them. I just used my truck here to show speed. Well, you may have also a direction associated with the speed. And so this is a typical Cartesian coordinate system, x, y, z. And my truck may be going 30 miles per hour to the right or in the x direction. And so now the truck has a speed and it has a direction, so it's considered a velocity, and that's a vector quantity. And then finally, acceleration would also be a vector quantity. Next, I'd like you to take some time and think about what is a force, or research what is a force. And is force a scalar or a vector quantity? It should be pretty obvious it's a vector quantity, since I just had it on my last slide. But why is it a vector quantity? Okay, now that you've answered that question, a force is just typically a push, or as simple as a push or a pull on a body. So if I push on this desk or pull on this desk, the action is a force. And so that's the concept of a force. And it is a vector, as I said, because if I push, it has a magnitude and the direction I'm pushing that I have to associate with it, or pulling for that case. So here's how we would completely describe a force. This is an example of a golf ball. A golf ball typically gets about 8, sometimes as high as 10 kilonewtons of force at impact. So I've drawn an 8 kilonewton force here. It's acting to the right, and I have my Cartesian coordinate system, I and j. And so the force can be described as 8 kilonewtons to the right, or 8 kilonewtons in the I direction. So I have my magnitude, I have my direction, and the other thing you want to also include always is the units themselves, so that we know it's in kilonewtons, and that's the SI system rather than pounds. So that concludes today's module.